Have you ever wondered how light-speed travel could be possible? It's a question that has tantalized scientists and sci-fi enthusiasts for generations. In the realm of science fiction, such a concept is not only possible, but often central to the narrative. Imagine, if you will, a trip to the farthest reaches of our universe, traversing light years in a matter of seconds. Now, let's bring this concept a little closer to the realm of the plausible, with a speculative mechanism known as the Higgs distortion drive. This incredible feat of imagination combines our current understanding of physics and a generous dash of creative extrapolation. It proposes a method of reducing a spacecraft's mass to zero, allowing it to achieve light-speed travel, or LST. It's a concept that's as fascinating as it is speculative. So, strap in and prepare for a journey of the mind. Now let's dive into the components of the Higgs distortion drive. First off, we have the Higgs field modulator. Now this isn't just your everyday gadget. Picture a device that generates and controls an outer Higgs distortion field. Sounds like something out of a sci-fi novel, doesn't it? But here's where it gets really interesting. This outer field could effectively reduce the mass of an entire spacecraft to zero. You heard right, zero mass, zilch, nada. How's that for a weight loss plan? So how might this work? Well, we're venturing into the realm of advanced quantum field technology here. It's all very speculative, but imagine that we could extrapolate the properties of the elusive Higgs boson in ways currently unknown to physics. Through highly advanced manipulation of the Higgs field at a quantum level, we might just be able to pull it off. The Higgs field modulator, a product of imaginative extrapolation, is the first step to making light-speed travel a reality. Next up is the quantum entanglement core. This crucial component has the vital role of managing the inner Higgs standard field. Now you might be wondering, what in the world does that mean? In essence, it ensures the standard mass properties within the ship, keeping everything from floating around like you're in a zero-gravity funhouse. How does it achieve this? Well, it employs an intriguing principle known as quantum entanglement. Picture this: two particles, light years apart, mirroring each other's state instantaneously. It's a strange concept, I know, but this is the weird and wonderful world of quantum physics. In our sci-fi scenario, the quantum entanglement core uses this principle to synchronize the ship's internal field with the normal Higgs field. This maintains a stable environment inside the ship, no matter how fast or far it travels. Imagine that, sipping your morning coffee at light speed without spilling a drop. The quantum entanglement core, a marvel of quantum physics, keeps the ship steady while in the void. Every drive needs a source of power, and ours is no different. The energy source, the heart of our Higgs distortion drive, is responsible for powering both the Higgs field modulator and the quantum entanglement core. Just like how a car needs gas, our drive needs a robust and efficient source of energy to function. But we're not talking about mere batteries or solar panels here. Oh no, we're venturing into the realm of the extraordinary. Imagine a zero-point energy extractor tapping into the boundless energy of empty space itself. Or consider an antimatter reactor, harnessing the raw power of matter and antimatter annihilation. Maybe even a compact fusion generator, mimicking the very process that powers our sun. These are the kinds of futuristic energy sources that could power our drive. These concepts may sound far-fetched with our current technology, but remember, we're painting a picture of possibilities, not certainties. The energy source, a beacon of futuristic technology, powers the drive. Now, let's talk about the field transition buffer. This little marvel is the guardian of balance, the master of equilibrium. It's the unsung hero of our light-speed travel. Imagine it as a cosmic DJ, seamlessly transition between two completely different Higgs fields, much like a DJ mixing two different tracks. Its function? It's simple but crucial. It ensures that we don't have a catastrophic rave when switching between the outer and inner Higgs fields. It's like the universe's most sophisticated equalizer, managing the transitions to keep things smooth and prevent any sudden drops or spikes. In terms of sci-fi mechanics, we're talking about a sophisticated system of field dampeners and regulators. These are not just your average dampeners. They must be capable of handling the titanic forces at play when dealing with quantum fields. This might involve exotic materials that we haven't even discovered yet, or principles of field dynamics that are beyond our current understanding. The field transition buffer ensures a smooth ride when switching between fields. Of course, we need a way to steer this ship, and that's where the navigation and control system comes in. Now imagine if your car's GPS was tasked with navigating not just city streets, but the vast expanse of the cosmos. Quite a job for a sat-nav, right? This is where our speculative sci-fi mechanism steps into the limelight. Picture an advanced artificial intelligence, a brainchild of the future, equipped with the computational prowess of quantum computing. This AI would be capable of calculating and adjusting the complex field dynamics required for light-speed travel. Think of this AI as the ultimate space chauffeur, constantly making minute adjustments to the spaceship's trajectory and speed. It would be like trying to thread a needle while riding a roller coaster, only 1,000,000 times more complex. But hey, no pressure for our AI, right? With the navigation and control system, we can navigate the cosmos at light speed. Now, isn't that a ride you'd want a ticket for? To keep the ship in one piece, we have the structural integrity field. Imagine it as the unsung hero of light-speed travel, working behind the scenes to ensure everything stays just where it should. The function of this component is truly critical. Without it, the stresses of light-speed travel could rip our spacecraft apart faster than you can say Higgs boson. The beauty of the structural integrity field lies in its ability to reinforce the molecular structure of the spacecraft. Through the wonders of advanced materials science, or possibly even nanotechnology, this field acts like an invisible, unyielding shield, maintaining the integrity of the spacecraft under extreme conditions. In the realm of science fiction, it's easy to get lost in the thrill of light-speed travel. But let's take a moment to appreciate the real MVP here, the structural integrity field. Without it, our dreams of traversing the cosmos at the speed of light would remain just that, dreams. The structural integrity field holds it all together when the going gets tough. Last but not least, we have the safety and life support systems. Now, while zipping around the cosmos at light speed is thrilling, it's a bit of a downer if we can't breathe, right? That's where these systems come in. They're the unsung heroes of our light-speed jaunt, ensuring the safety and survival of the crew and passengers. Imagine advanced life support systems that operate independently of the Higgs fields. These systems are like the best room service you've ever had, only instead of delivering fluffy towels, they're providing a stable and livable environment inside the spacecraft. How about recycling air and water with near-perfect efficiency, or a medical bay capable of regenerating tissue? Or perhaps an AI that monitors our health in real time? The possibilities are as vast as the universe itself. Remember, even in the wild frontier of space, safety is paramount. Safety and life support systems ensure our journey to the stars is a safe one. But let's not forget there are some serious considerations to take into account. First off, we can't ignore the elephant in the room: relativistic effects. As we approach light speed, time would slow down for those on board the spacecraft relative to the rest of the universe due to time dilation. This means, while you might be sipping space tea for a few minutes on your light-speed jaunt to Alpha Centauri, years or even decades could pass by on Earth. So unless you're a fan of being the ultimate time traveler, or don't mind coming back to a world where your favorite TV show is now considered a classic, this could be a significant issue. Next up, navigational challenges. Let's be honest, space is not exactly empty. It's filled with asteroids, space dust, and all sorts of cosmic particles. Now, imagine hitting one of these at light speed. Ouch. That's not a fender bender, it's more like a cosmic obliteration. So we'd need a way to predict and avoid potential collisions. Maybe some sort of super advanced predictive modeling, or exotic sensors that make our current radar look like a child's toy. The possibilities are fascinating, but also quite daunting. And finally, the energy requirements. Even in our wildest dreams, powering a Higgs distortion drive would require an immense amount of energy. Imagine trying to power a city, no, a country, with a single generator. That's the sort of challenge we're talking about here. We'd need a highly advanced and efficient power source, something that goes way beyond our current technological capabilities. Who knows, maybe we'll discover a new form of energy in the future. One can dream, right? While light-speed travel remains a dream for now, who knows what the future holds?